In this video, we're going to discuss two final quantities, two final parameters associated with a bandpass filter. The first of these is known as the bandwidth, or beta. And beta is simply defined as the width in frequency, or the channel frequencies that will be passed by the bandpass filter, and is equal to the upper cutoff frequency minus the lower cutoff frequency. Or beta, as it's called, is equal to omega C2 minus omega C1, which then is equal to, as we've seen, omega, the upper cutoff frequency is R over 2L plus the square root of R over 2L quantity squared plus 1 over LC minus the quantity negative R over 2L quantity squared plus the square root of R over 2L quantity squared plus 1 over LC. So distribute the minus sign through to both of those, and we get then that the radical terms add to 0. The R over 2L squared terms, oops, that's not supposed to be squared. The R over 2L terms add, and so we get that beta is equal to R over 2L plus R over 2L, or R over L. So the bandwidth, or the width between the two cutoff frequencies in a series bandpass filter, is just the ratio of the resistance to the inductance. With this, and with omega naught squared equaling 1 over LC, we can now write the transfer function h of s in terms of beta and the cutoff frequency, or beta and the resonant frequency. So it turns out that h of s is equal to beta s over s squared plus beta s plus omega naught squared. And the two cutoff frequencies, omega c1 then, in terms of beta and omega naught, omega c1 is equal to negative beta over 2 plus the square root of beta over 2 quantity squared plus omega naught squared. And the second cutoff frequency, omega c2, in terms of beta and omega naught, is positive beta over 2 plus the square root of beta over 2 squared plus omega naught squared. Now, one final value, or one final measure, parameter of a bandpass filter, is known as its quality, or Q. So the quality of a filter is equal to the ratio of omega naught divided by beta. If you stop and think about this, we have up here at some omega naught a bandpass filter of sorts, where that is the bandwidth. So the quality of the circuit is equal to the ratio of its center frequency divided by the bandwidth. It's something of a feel for how quickly the filter falls off, or how narrow its bandwidth is relative to its center frequency.